this video we will discuss about numerical problem based on the OBST to get the OBST and its expected searching cost. So input is given, so that is the actual keys and the probabilities of the actual keys and the probabilities of dummy keys. So there are 4 actual keys starting from K1, K2, K3, K4. As there are 4 actual keys, so there will be 5 dummy keys starting from D0, D1, D2, D3 and D4. So to get the OBST, so there are 3 tables we have to develop. First table is sum of the probabilities. Now here sum of the probabilities should be the 1. It means that if you take the sum of the probabilities of actual keys and the dummy keys, we will get the 1, and this cell gives us the probability 1. Then next table is E table. It is called expected searching cost. Now here structure of W table and E tables are the same. In E tables we get expected searching cost of the OBST, and this cell gives us the expected searching cost of the OBST. And last table is the root tables. Here the structure of the root table is same as that of W table and E table, except the bigger diagonal is removed in the root tables. If you see, now this diagonal is removed in the root tables, and the rest of the diagonals are same as that of W table and the E table. In W table, J starts from 0 to N is nothing but the number of actual keys, and I starts from 1 to N plus 1. Similar way, in E table, J starts from 0 to N and I starts from 1 to 5. In root table, J starts from 1 to N and I starts from 1 to N. Now let us see how to fill W tables. Now here first we have to write the values in the bigger diagonals from the probabilities of dummy keys. So there are the 5 dummy keys having the 5 probabilities, so that we have to put in the bigger diagonal. So start from the point 1, then point 2, then 0.05, then 0.05 and 0.1. Now similar way, in E table also we have to put the probabilities of the dummy keys, means these values. So once we have put the probabilities of dummy keys in bigger diagonal, now the same probability has to be inserted in the bigger diagonal cells. That is 0.1, 0.2, 0.05, 0.05, then 0.1. Let us see how to fill up W tables. Now here we have to fill up the W tables in row wise and E tables in diagonal wise. Now first we will fill up W tables in the row wise. Let us see how to fill up W tables. Now first try to get the value for this cell. For that we have to consider the value from the previous cell, that is 0.1, and take the sum of the probabilities of actual key K1 and dummy key D1, that is this one. So the probability of K1 is 0.1 and probability of D1 is 0.2. 0.1, 0.2. Take the sum of this, it comes to 0.4. So write here 0.4. Find out the value of this cell. For that we have to refer the previous value, that is 0.4, and the probabilities of K2 and D2. So probability of K2 is 0.05, probability of D2 is 0.05. 0.05. Take the sum of this, it comes to 0.50. So write here 0.5 for this cell. So we have to refer the previous value, that is 0.5, and add the probabilities of actual key K3 and dummy key D3, that is 0.15 plus 0.05. 0.15 0.05 is equal to 0.7. 0.7. Now then, for this cell, so refer the previous value, that is 0.7. Then take the probabilities of K4 and D4. We have the probability of K4, that is 0.2. We have the probability of D4, that is 0.1. 0.2, 0.1. Take the sum of these values, it gives 1.0, means 1. Here we have got 1, which gives the sum of the probabilities of actual keys and dummy keys. In OBST problems, always we get 1 here. Now after that, try to get the values for the second row. This one. Now refer the previous value, that is 0.2, and take the sum of the probabilities of K2 and D2, that is these values 0.05, 0.05. Take the sum of this, it comes to 0.3. For this one, so consider the previous value, that is 0.3, this value. Then take the probabilities of K3 and D3, 0.15 and 0.05. It comes to 0.5, means 0.5. 0.5. And for this, refer the previous value, 0.5. Then take the probabilities of K4 and D4, 0.2, 0.1. It comes to 0.8. 0.8. Now similar way, try to get the values for third row, starting from this. So for that, so refer this value, 0.05 plus, take the probabilities of K3 and D3, that is these values, 0.15, 0.05. Take the sum of these three values, that is 5.25, 0.25. Then for this cell, 0.25 plus the probabilities of K4 and D4, that is 0.2 plus 0.1, it comes to 0.55. Then the next row, this one, for this cell we have to refer the previous value, 0.05 plus the probability of K4 and D4, K4 and D4, 0.2, 0.1, it comes to 0.35. So in this way, we have developed the W table, that is sum of the probabilities. Taking the reference of W tables, try to get E table. We have to fill up the E tables diagonal wise. First find out the value for this cell, then for this cell, for this cell, then this cell. Now first we'll try to get the value for this cell. Now here, for this cell I is 1 and J is 1. It means that I is less than equal to R less than equal to J. We know the value of I, that is 1, less than equal to R less than equal to 1. This is for this cell, and value of R is nothing but the 1. Value of R is nothing but the 1. Right? Now let us see how to get the value for this cell. Now for that we have to refer the previous value, that is 0.1, and we have to refer the value which is in down cell, as well as we have to refer the value in W tables which is at 1 cell. Value in W tables at 1 cell is 0.4. Now first I take 0.1 plus 0.2 plus 0.4. It comes to 0.7. So write the 0.7 in 1 cell, and we have got the 0.7 for R is equal to 1. Now here, while filling the E tables, we have to fill the root tables simultaneously. Here we have got 0.7, 0.7 for R is equal to 1. So that's why put R is equal to 1 here, 1 cell. Now then, try to get the value at this cell. For that, we have to refer previous value and the down value, and the value in W tables at 2 positions. At 2 positions, value is 0.3. So 2 less than equal to R less than equal to 2. Here R is equal to 2. R is equal to 2. Previous value is 0.2 plus down value is 0.05 plus the value in W tables at this cell, that is 0.3. It comes to 0.55. Now then, try to get the value for this cell. Here we have got 0.55 for R is equal to 2. So that's why put here 2. Now then, try to get the value for this cell, that is 3 cell. Here 3 is less than equal to R less than equal to 3, means value of R is 3. Now consider previous value and the down value. 0.05 plus 0.05 plus the value in W tables at 3 positions. Value in W tables at 3 position is 0.25. 0.25. It comes to 0.35. 0.35. We have got 0.35 for R is equal to 3. So put here value 3. Now then, for this cell, means 4 cell, consider previous and the down value. 4 is less than equal to R less than equal to 4. Here R is equal to 4. So previous value is 0.05 plus the down value is 0.1 plus the value in W tables at 4 position, that is 4 position 0.35. 0.35 is equal to 0.5. So we have got 0.5 for R is equal to 4. So put 0.5 and R is equal to 4 in root table. So in this way we have completed this diagonal in E tables as well as the root tables. Or directly you can put 1, 2, 3, 4 in first diagonal of the root table without considering this value. Now then try to fill up these cells in E tables. Let us find out the value for 1, 2 cell. Here I is equal to 1 and J is equal to 2. I is equal to 1, J is equal to 2, means R start from 1 to 2. First we consider R is equal to 1, so you will get the 1 value. Then consider R is equal to 2 for the second value. So out of this we have to consider the minimum value. Now let us see how we will get the two equations, one for R is equal to 1, another for R is equal to 2. For this cell on left sides there are two values. Out of this we have to consider the last value, and in downside we have to consider first value, that is 0.55. 0.1 plus 0.55 plus, and consider the value at 1, 2 position in W tables. In W tables 1, 2 position value is 0.5 is equal to. Now then for R is equal to 2. For R is equal to 2 we have to consider this value. In downside we have to consider the last value, that is 0.7 plus 0.05 plus value at 1, 2 position in W table, that is 0.5, means this value 0.5 is equal to 1.15, 1.25. So out of these two values minimum is 1.15. So write 1.15 at 1, 2 position, 1.15. We have got 1.15 for R is equal to 1. So put 1 in root tables at this position. Now then try to get the value for this cell. 2 less than equal to R less than equal to 3. R varies from 2 to 3. Again you will get the two equations. First for R is equal to 2. For R is equal to 2 we have to consider the last value in left side and first value in downside. 0.2 plus 0.35 plus value at 2, 3 position in W tables, that is 0.5. 0.5 is equal to. Now then equation for R is equal to 3 is, in left side consider the nearer value 0.55, in downside consider the last value 0.55 plus 0.05 plus 0.5 is equal to 1.05 and 1.1. So out of this 1.05 is the minimum for R is equal to 2. Put here 1.05 for R is equal to 2. Now then, try to get value for 3, 4 cell. 3 less than equal to r less than equal to 4. So r varies from 3 to 4. You will get two equation, one for r is equal to 3 and another for r is equal to 4. First we try to get the equation for r is equal to 3. Now here in left side we have to consider last value and down side we have to consider the nearer value or first value. 0.05 plus 0.5 plus the value at 3-4 position in W tables. 3-4 position, that is 0.55 is equal to. Similar way, try to get the value for r is equal to 4. So in left side we have to consider nearer value. In down side we have to consider the last value. 0.35 plus 0.1 plus 0.55 is equal to 1.1 and this value is 1. So out of these two values, so 1 is minimum for r is equal to 4. So put 1 and here r is equal to 4. So in this way we have completed these diagonals. Now we will go for filling the values for this diagonal, these two cells. Cell is 1, 3. 1 less than equal to r less than equal to 3. So r varies from 1 to 3. R varies from 1 to 3 means you will get 3 values. First for r is equal to 1. Now let us see how to get the values for. Now in left side we have to consider the last value 0.1 and down side we have to consider the nearer value. 0.1 plus 1.05 plus the value at 1,3 cell in W table, 1,3 that is 0.7. 0.7 is equal to. Then for r is equal to 2. For r is equal to 1, we have considered 0.1. Now consider 0.7 for r is equal to 2. So 0.7 plus in downside for r is equal to 1, we have considered 1.05. Now consider 0.35. 0.35 plus w value, that is 0.7 is equal to. Then value for r is equal to 3. So in left side consider the nearer value 1.15. 1.15 plus in downside consider the last value, that is 0.05 plus 0.7. In this way we have got 3 values: 1.85, 1.75, 1.9. So out of this, so 1.75 is the minimum. So right here 1.75. We have got 1.75 for r is equal to 2. Means, so right here r is equal to 2. Then try to get the value for this cell 2, 4. 2 less than equal to r less than equal to 4. R varies from 2 to 4. R varies from 2 to 4. R is equal to 2. Apply the same concept that we have discussed for 1.75. For the first value, we have to refer 0.7 and 1. 0.2 plus 1 plus the value at 2, 4 cell in W tables, that is 0.8. 0.8 is equal to. Then for r is equal to 3. 0.55 plus 0.5 0.55 plus 0.5 plus 0.8 is equal to, for r is equal to 4, 1.05 plus 0.5 plus 0.1 plus 0.8 is equal to 2, 1.85, 1.95. So out of this, minimum is 1.85. Right here 1.85. We have got 1.85 for r is equal to 3. So right here 3. So in this way we have completed these cells in E tables as well as the root tables. Now next cell which gives us expected searching cost, that we have to calculate it. So last cell is 1 4, 1 less than equal to r less than equal to 4, r varies from 1 to 4. For r is equal to 1, you will get the equations as per the discussions for the previous cells. For r is equal to 1, we have to add 0.1 with 1.85, 0.1 with 1.85 plus the value at 1 4 position in W tables, that is 1, is equal to, the next value for r is equal to 2. We have considered 0.1 for the previous r, now consider 0.7. Similar way, we have considered 1.85 for the previous r, now consider 1 plus 1 is equal to, then for r is equal to 3, add 1.15 with 0.5, 1.15 with 0.5 plus 1 is equal to, then for r is equal to 4, add 1.75 with 0.1, 1.75 with 0.1 plus 1 is equal to 2.95, 2.7, 2.65, 2.85. Out of these 4 values, 2.65 is minimum. So write at this cell 2.65, and we have got 2.65 for r is equal to 3. So write here r is equal to 3. In this way we have developed W table, E table and the root tables. Now for getting the OBST, we have to refer the root table only. From E tables we will get the expected searching cost from this cell. Here expected searching cost is 2.65. Now let us try to get the OBST from the root tables. We will start developing the root tables from the 1 4 cell. It means R14, root 14. At root 14 the value is 3. Now then, so there will be 2 children for this parent, that is left child and the right child. R, so write 1 here, comma, dash. Similar way, at right side, write dash, comma, 4. We have to fill up the value for this dash. Now, at 1 4 position, value is 3. Now, to get the value at this position, we have to subtract 1 from this, means minus 1. 3 minus 1, that is 2. So, write here 2. And for the right side, we have to add 1. 3 plus 1, that is 4. 4 will come here. Right? Now then, find out the value at 1 to cell in root table. So 1 to cell value is 1. Now then we have to expand this to get left and the right child. R1 will be as it is, dash, then R dash comma 2, minus 1 plus 1. 1 minus 1, that is 0, 0 will come here. 1 plus 1, 2. Then find out the value at this cell 1 0 1 0. So there is no 1 0 cell. That's why we have to stop the processing at this place. Now once it is stopped, we will get the dummy keys. So already we have discussed dummy keys are always at the leaf node. That is D, J is 0, D is 0. And it is represented using rectangle. Then for this R22, let us see R22 is there. Yes, 22 cell is there, and value at 22 cell is 2. This value. Here these values are represented in circle, means these are actual keys. And the values which are represented in the rectangle, these are dummy keys. Now try to expand this. Here I write R2 comma dash, R dash comma 2, 2 comma dash, R dash comma 2. Then what will be the value for these positions? Now here this side subtract 1 from 2, that is 2 minus 1, and 2 plus 1. 2 minus 1 1, 2 plus 1 3. Now which value is at 2 1 cell? See here 2 2 1. So there is no cell in root tables. So that's why we have to stop here with the value D. J is 1, D1. Now let us see which value is at 3 2 position in root table. 3 2 2. So there is no cell in root tables. So that's why we have to stop with D, and J is 2. Then try to get the left and the right child for this node. R4 4, 4 to 4, value is 4, means we have got actual key. Expand this with left and right child. R 4 comma dash, R dash comma 4. Find out the value for these positions. Now here subtract 1 from 4. 4 minus 1, that is 3. And add 1 to this 4. Means 4 plus 1, that is 5. Now find out the value at this cell in root table 4 3. 4 2 3. So there is no cell in root tables. So that's why we have to stop here with D, and J is 3, D3, and R5 4. So there is no cell in root table. So that's why we have to stop with D, J is 4, D4. Now from this tree to get the final OBST. Now here circle are represented for actual keys and rectangles are represented for the dummy keys. Now try to draw the final OBST. So this is 3, means we have got K3, having two children, left and the right. This is 1, means we have got the K1 node. This is 4, means we have got K4 key, actual key. Now then this side, expand this K1. Now here D0, means we have got D0 dummy keys. Then this side we have 2 in circle, means we have got K2, right? Now then expand this K2. So here is D1, that is dummy keys. Here is D2, so write D2 as it is. Okay. Now then try to expand the K4, this one. Now it has D3 as a left and D4 as the right, the child. D3, D4. In this way we have obtained the OBST. So this is the final OBST and expected searching cost is 2.65. This is required OBST and its expected searching cost is equal to 2.65. In this way we have got the OBST and expected searching cost, that is 2.65. In next video, so we will discuss another problem based on the OBST.